Okay, today we're going to see this example on the screen and how we actually do the bond graph model. So what I recommend is that we recognize the different loops here. Like for example, we could call this one I1. We could call this I sub 2. We could call this I sub 3. This one we could call it I sub 4. And this too, I sub 5. Okay? Although we don't have any element is open, but I am going to put a voltmeter basically here, which is a high input, high impedance element. So basically the current is 0, but the voltage is not. So I just for helping myself to do this thing and make it easier. So this is going to be I1. And I put another one junction for I sub 2. I will put another one junction for I sub 3. I will put one junction for I sub 4. And I will do another one junction for I sub 5. Yeah? Okay. So then the second step is to add the elements that actually see this currents, and so you can easily identify this one over here as a, well, maybe we should change colors here to make it a little nicer in here. So let's just do this one is your I element, which has value L sub 1, and you also have the C element, which has value C sub 1, and you have an input in here which is a source of effort with value E, and this one we know because it's combined. This is, you can do anything, but in here on I sub 2 you have one that is a source of flow with value I, and then you have another I element with value L sub 3. You have I sub 2, we also have the C element with value C sub 2. Yeah, in between, well, let's just do this one. The only one that we can do for this is the R element with value R sub 4, like this. This other one in here, this is an important one. I am going to model this as a source of flow with I equals to 0. So this is going to be like this, and the way you model this is you put a little arrow like this, which means it's an activated bond. That means you measure the voltage, but the current is 0. So in here on this one, on I sub 5, I have the C in here, see, with value C sub 3. And this is all I can say about the elements that have currents, that are directly connected to the currents in the loops. So this has set up the structure of my modeling here. What I need to do now is to establish the relative currents or the current differences so that I can model the elements that see those differences. So for example, the one that I can see that is in here would be important to determine is You see you have I1 and you have I sub 2 over here. This element over here, see the difference between this and this one. So what I need to do, you say I1 minus I sub 2 is done like this. And then this would be I1 minus I sub 2. And on that, we put the element, the C element, which is, no, it's an I element, right? Sorry, I think I messed it up in here. Yeah. So this would be the I element with value L sub 2. Yeah. Over here between I1 and I sub 3, we have also a 0 here, and the difference is I1 minus I sub 3. You have this R element in there with value, what was R1, right? This I think is R1. And then between these other two, I2 and I sub 3, you have also a 0 like this. This would be I sub 2 minus I sub 3. And from here you can see you will place this C element, which has a value C sub 2. In between I sub 3 and I sub 4, you have this transformer element, see? That is easy. And then you have on this I sub 4, this R, and in between these two you have a 0, and then you have a 1 junction, which is I sub 4 minus I sub 5, and on this you have this R element. Now when you only have one element like this, when you have one element like this, you have a situation where you can simplify this, and the same thing is true is here and there, and you could get the bond graph simplified. But if you leave it like this is perfectly acceptable, and it would be fine for computer simulation for doing the CAMG software. Yeah.
The element attached to the I2 minus I3, are you sure that isn't supposed to be R2?
No, it's C sub 2. See here?
Yeah, how about, where's that R sub 2 then?
Which one? R2?
Yeah. Shouldn't be right where your cursor is right now.
R2 is between I2. That, yeah. This is an error. This one is R2. Let's correct that. Thank you. With value R sub 2. There we go. Anything else? Okay. What I have told you is, if you have this model like this, you should be able to model this into the CAMG software as is. CAMG will assign the phone numbers, and we do the causal marks and everything. But what I'm saying is, you'll be ready to enter this into the computer. But for practice, I would like to do the causal assignment in here. And so In here, what we're going to do is let's just go in here and what did I just do? Okay, so I need to have a pen that we can actually see, and I'm gonna choose the red one. Okay, so what do you do first? You assign it to the sources and see if you can propagate any causal marks. Here, no. This, you assign it to this, yes, because this determines the flow here. Then the others have to be like this, see? Which right there puts this in derivative form. So, but that's the way it is this. This one will have the causal marks like this, and then if you put this in integral form, the others will have to be like that, and this. Okay, now we go to this other I in integral form, makes this one like this, and that's a problem because you cannot this cannot be done. Do you see all of this? That is not possible. The moment that we did this and did this, then this is in derivative form. So I need to erase that again, this mark and this mark. So because of the way it is structured in there, this one will be like this, and that makes this also in derivative form. Okay, so this one's based on this, they are like this. That one is okay, it's in integral form. Anything else that determines the yeah, this system looks like it has several complications because you see the causal marks would not complete over here, nor here, nor here, unless we assign one to the R element. And that's what we may have to end up doing it. But yeah, so when this happens, you have to assign it to one of the R's, which means you will have an algebraic loop on the equations. And when you do this, then it forces this to be like that, sets the flow, and it forces this other two to be like this. When it's that this, it forces this like this and like this. So this causal mark for the TF has to be like this, and that completes for these other two. You have these two flows, and then the effort is like this. Yep. So it had only one, but this is the final assignment as it would be done. Yeah.
So on the far left, the I element that has got the causal mark putting the effort away from it, would that mean that we wouldn't be able to use this for computational purposes?
Right now, you don't know yet how to do that. We will look at this. In this case, this is not impossible circuit either. I'm not trying to say that. I'm just saying that at this point, you don't know yet how to deal with systems with derivative causal or with algebraic loops, and this system has both of those. So it has a bit of a challenge, but not, it's not impossible to solve. But this is the bond graph model for the system.